So what I want to do, you've had a go at defining take, and just to remind you what we were doing here, we have a function that takes the first n elements from a list. So for example, we've got take of 0 gives us an empty list, and if we take 9 of hello, we can't get 9 elements, but we can get as many as we get as many as we can. So here we get 5. Okay. So and also remember we had the templates for integers and lists, and then we wanted to think about how we were going to do this. So let's think about what we're going to do with take. What should we do? Well, we can say that take 0 from any list at all, let's say underscore x's, is going to be the empty list. We can say that taking any number, not minus n, but underscore n, from an empty list can only give us an empty list, because there's nothing else to give. Now, what will be the case now? We've eliminated the case where we're asking for 0, we've eliminated the case where we've got an empty list. So we can say that we'll have n arguments, and we will have a non-empty list, x, cons, x's. We might like to say n is bigger than 0, just to be sure. And then, what do we want to say? What we're defining is taking n elements from this list, x, cons, x's. Well, we could do recursion on n, we could do recursion on the list. In fact, what we're going to do is do it on both. We'll define a new list, the answer is x, cons, and what do we want? We want to take n from the whole list, so we want to take n minus 1 from the tail. And there we have our answer. And that looks fine, and let's make sure that we export it. Take 2, and we'll save that. We'll compile where 1. Whoops, oh, we better go into Erlang first. Erlang, compile where 1, and then we can say where 1, and then we can try our examples. Take 0 from hello, take 4 from hello, take 5 from hello, and take 9 from hello. Okay, so there we've got our definition, and it gives us the behaviour that we wanted. So we've defined it for ourselves. In fact, there is something else in the lists module. We could take a look in the lists module, and we would find that there is something suitable. Now, let's just escape from there, and I'll show you this in the shell. So we can say lists colon split, let's say for and hello, and what split does is not only give us the take, but it also, as it were, gives us the drop. It gives us what is left after the split. And if we do that with 5, we get what we wanted. If we do it with 9, we don't get what we wanted, because lists split has a rather different behaviour. So let's perhaps, what we need to do perhaps is to take a look at, in a bit more detail, at what's going on in that example. We've seen that it gives an error. Let's look at what the definition looks like. Well, here's a way of defining take. We can reuse that function, even though it doesn't behave quite as it should, in this sort of way. We call lists colon split, and we just throw away the second half, because as we saw, it gives us the take that we're interested in as the first of 2 elements in a pair. So what we want to do is just return the first of those 2 elements. So there's another way of defining take. We can actually reuse that function. So one of the ways we can reuse something that's already there is to call it. Perhaps wrap it in something in order to get the answer we want. But the other thing we can do is reuse the definition. Now let's have a look at what split is doing here. In fact, what split does is do a tail recursion for us. Split has a 3-argument split where the second argument is the list that we're pulling apart, and the third argument we build up the take backwards. So we build up the take in reverse, and then when we get to the base case, when we're not taking any more, we're splitting at position 0, we reverse the last value to give us what we were looking for. But you can see that we never go, as it were, lower than 0. If we hit that last case where we have an empty list, we run out of list, as it were, before we're able to get to 0, we get a bad arg. Now what we could do is modify the definition to do something that we wanted ourselves. Now here's a way of transforming that definition just to give us the take. What we've done is just copy the definition, and in fact it works exactly the same way, except that on the final case, on the first clause in the 3-argument take, we just return the first half. So there we've redefined the function so that we get what we need, but we can actually modify it so it behaves as we would like it to behave. And what we do in that case is we transform the last clause, which used to say if you get to an empty list then you've got a bad arg, and we transform that and say okay, we've run out of lists, but the answer is just to reverse what we've got so far. And if we do that, then we get precisely the behaviour we want. So if we take 9 elements from hello, we'll still get back the answer hello rather than a spurious answer. So you can see we had 3 strategies there for defining take. The first was to define it ourselves from scratch using recursion. The second was to see that we could define take using a built-in function, albeit with slightly different behaviour. And the third approach was to take that built-in, already defined function and modify its definition somewhat. Now what I wanted to finish with in this section was just to show you how I get the documentation about lists. I type into Google Erlang lists, and this takes me, the first hit is indeed the Erlang lists module. And what this gives us is the lists module, and you can see here it gives a whole collection of things. In fact, one thing it doesn't do is define a take function. So you think, oh, perhaps we can't define take. But if you think about it, if we go to split, and you can see we've got an index there. Split takes a list, a number of the list, and returns us 2 lists. And it splits list 1 into list 2 and list 3. List 2 contains the first n elements. So you can see that this gives us what we would like. Now, as I suggested when we looked at this earlier, best way to find out about an Erlang module is put into Google Erlang and then the name of the module. You'll find that as first hit, or if not first hit, very close to the top of the list of hits. So, and you can see there's a huge variety of list functions here built in. So often what you might want to define is already defined in here. But it'll be useful for us, and it's good exercise, good programming practice to try defining some of these things for ourselves. But you can always try and take a look in here and see if there's a function that does what you want, or does enough of what you want in order to give you what you would like. Okay, so we've looked at that first example. What we'll do next is look at a more complicated example.